Hello dear students, so I'm here with the third lecture of the NSEJS 2025 series. I'll quickly show you what we are going to cover in this series and currently what is going on. So in this series, these are the chapters that we are going to cover in the same sequence that is listed here, and currently we are doing basic mathematics, okay, or you can say mathematical tools. Okay, this is what we are covering. Within mathematics also, these are the areas that we need to cover, and this is the third lecture of the series, and in the previous two lectures we have covered the trigonometry part that we are going to need. Okay, today we are going to talk about coordinate geometry, determinants and functions. Again, these are all independent chapters of grade 11th and grade 12 mathematics, so obviously we are not going to cover them in that detail, but we need some exposure. Okay, so that exposure is what I'm going to give you. In coordinate geometry, we are going to learn about marking a point in xy plane, about marking a point in 3D space, and about slope of a straight line. And then in determinants and functions, there are a few things that I want to tell you. We'll start with them. So let's start with the coordinate geometry. How do we mark a point in xy plane? So guys, let's say this is x-axis, let's say this is y-axis. That's the usual way of making the x and the y-axis. And suppose I say that a point has coordinate 3, 4. So what does that mean? Okay, saying that, so the this plane has got addresses. Each point has got an address, and these coordinates, we call them the coordinates, or we call this as the ordered pair. In bracket, when you mention two numbers like this separated by a comma, this is called an ordered pair. Okay, the first number represents the x coordinate, the second number represents the y coordinate. Okay, x coordinate indicates the amount of distance that we need to walk along the x-axis. Remember, x-axis is a number line, so there would be numbers written here. Okay, I have not written it, but it would be there. Similarly, y-axis is a number line, so there would be numbers written on the y-axis also. So 3 means that you start from the origin and you walk 3 units along x. Okay, comma 4, that would mean after that you walk 4 units along y. Okay, so 1 2 3 4, and then you will reach somewhere here. Okay, so this point would be point A. So realize this thing, that each point on this plane has got a unique address. Okay, and we can reach that point by walking parallel to x and y axis. There is one other important thing that you have to note. You can choose to first walk along y axis. That is your choice. Suppose you decided that I will first walk along the y-axis, but remember, the second number represents the y coordinate and the first. So even if you choose to walk along the y-axis, you will still be walking 4 units. So you can walk 4 units and then you can walk 3 units. You will again end up at the same point. So this is how we mark points on the xy plane. Okay, and I think you will remember this. This is called the first quadrant. This is called the second quadrant. This is called the third quadrant, and this is called the fourth quadrant. Okay, so guys, let's do one exercise. Let me mention a list of points, and then we will try to mark them in the xy plane. Okay, so let's say point A has a coordinate of, let's say 10, 7. Okay, point B has a coordinate of -4, let's say 5. Okay, point C has a coordinate of -6, 6, let's say, and D has a coordinate of, let's say 8, -3. All right, so let's see how we can mark these 4 points. Okay, so I will first make the coordinate axis. Okay, and now let's see. Okay, I will also make some divisions. So 1 2 3 4 5, 1 6 7 8 9 10 11 12 13 14 15. Okay, here also let's do it. 1 2 3 4 5, so that is -5 actually. Okay, 6 7 8 9 10, that's -10. 11 12 13 14 -15. Okay, in y direction 1 2 3 4 5. Of course, these distances are supposed to be equal. I'm doing the drawing with a free hand, so they may not look equal, but if you use a graph paper, this problem will not be there. Okay, so okay, I'm just trying to give you the best possible interpretation. Okay, so 1 2 3 4 5 6 7 8 9 10 11, 12, 13, 14, 15, and that should be okay. Now the first point is 10, 7. Okay, so this is 10, this is 7, so this would be point A, 10, 7. Okay, and this would be a point in the first quadrant. If you notice, guys, if a point has both positive coordinates, okay, then it will be in the first quadrant. So in first quadrant, x is positive, y is positive. Okay, then B is -4, 5. Okay, so -4, that means I will move along negative x-axis 4 units. Okay, so this is -4, 5, that would be this. So this is the point which is B. And if you notice that if the x coordinate is negative and the y coordinate is positive, then we end up in the second quadrant. Okay, then -6, 6. So -6, 6 would be somewhere here. So this is point C. And you can notice in third quadrant both are negative. Okay, then 8, -3. So this is 8 and this is -3. So this would be point D. And you can see that in fourth quadrant x is positive and y is negative. So this is how we can mark points in xy plane. Okay, I hope that part is clear to everyone. Okay, now there are few other points here that you can notice, guys. These are not relevant right now. Okay, I'll ignore them right now. We'll make use of them when we need it. So I hope marking a point in the xy plane is very clear to you. Let me give you a homework question. Okay, so suppose I made a triangle. Okay, this is an equilateral triangle. Okay, and this length is 2 meter. So can you tell me the coordinate of the vertices of this triangle? Okay, what are the coordinates of this? Is x-axis, this is y-axis. This is your homework. You can respond in the comments and you can let me know the answer. Okay, now we'll go to marking a point in 3D space. Now before we start doing that, we need to first have clarity what exactly is 3D space. So guys, though some of you would be aware that how do we mark z-axis. So if this is x-axis, if this is y-axis, then z-axis is the one which is coming out of the plane of the board, which is coming outward, and therefore we can't draw it in the board. Okay, the best way that we can do is we can draw a slanted line indicating that this line is coming out of the board. Okay, so this is called the z-axis. Okay, now those of you who are familiar with this fact that z-axis is drawn outward, you may not be familiar with this, that this is called a right-handed system. This is called a right-handed system. What does that mean now? Okay, so guys, from among 3 axes, you have the liberty to choose any 2 axes in any 2 direction. Of course, you have to keep them perpendicular to each other. So I chose x, I chose y. Okay, I chose x in this direction, I chose y. The moment I fix x and y, z-axis gets auto decided. Okay, because if we have chosen right-handed system, it means that you will use your right hand. Okay, you will place your right hand parallel to x-axis, and then you will try to turn this right hand towards y-axis through the angle between them. Okay, in doing this process, you have to keep your thumb at 90 degree with your finger. Okay, in doing this process, wherever your thumb points, that is the direction of z-axis. So my thumb points outward, so that is the direction of z-axis. So this is why it is called a right-handed system, because we are using right hand to determine the direction of z-axis. Okay, let me further explain this. Suppose if I have chosen this as the x-axis and let's say this as the y-axis. Okay, in this system, can we do that? Yes, we can do that. It is up to you where you want to choose. So now x is towards that direction. If I turn my hand towards y, my thumb is inward, it is into the screen. So the z-axis is going inside the screen in this case, and we will draw it like this. Like, that is the best way to draw it, like not the most efficient, but given the circumstances, given that the fact that z-axis is perpendicular to the axis, this is what we can do. Okay, why do we draw slanted line? I'll give you a hint. See, if you draw a cuboid, you will realize that the corner of a cuboid has a situation like this. Like in the corner of a cuboid, you have three lines which are intersecting and which are perpendicular to each other. So in this cuboid, it is pretty evident that where this third edge is going. So you see that this is the diagram we generally draw to represent the three axes together. Okay, getting it? I hope the right-handed system is clear to everyone. Okay, let me try once more. So if I say that, okay, this is x-axis and this is y-axis, where would be the z-axis? Okay, so x is downward, I will turn my finger towards y, so my thumb is still pointing inwards. So even in this case, z is inward. Sometimes we use a cross to indicate inward direction. So z is here and it is inward. Okay, now right now what I'm doing, I'm fixing x and y and then I'm trying to find out the direction of z. Can we do it other way around? What if I decide that I will draw y and z according to my wish and then I will try to find out the value of x or the direction of x? You can do that. You have to remember a rule. If you are using x and y, then go from x to y and your thumb will give you z. If you are using y and z, go from y to z and your thumb will give you x. If you are using z and x, okay, then go from z to x, your thumb will give you y. I'll demonstrate. Okay, remember this diagram, x, y, z in clockwise direction. Okay, so suppose I choose z in this direction and y in this direction. Now I ask that where is x-axis? So I will start from y, I will turn my fingers towards z, okay, y, z, y to z, and thumb is inwards. So in this diagram, x is inwards. Okay, what if I choose, let's say this is y-axis and let's say this is z-axis. Now where is x now? So I will start with my right hand, I will place it towards y, I will turn it towards z, so x is outwards now. In this direction, in this diagram, outward. And outward is denoted by a dot many times if there is a need. Okay, so in this, z is x is outward. So you can remember this rule. Okay. Now marking a point in 3D space. So earlier we talked about an ordered pair in which two numbers were mentioned. If three numbers are mentioned, then the first number indicates x-axis, sorry, x coordinate, the second number indicates the y coordinate, and the third number indicates the z coordinate. Okay, so if I say that point A has coordinate of 2, 3, 5, let's say. Okay, I've written the number randomly. Okay, then, and if I ask you to mark this point, then let's say this is x-axis, let's say this is y-axis, let's say this is z-axis, then you will do this: 2 along x, 3 along y, and 5 parallel to z. See, this is parallel to z, so this would be point A. Okay, of course this diagram may not be that clear, so let me give you another diagram to make it clear. Okay, and for that let's draw a cuboid. So let's say this is a cuboid. Okay, let the length be this is 7. Okay, this is 4 meter. Okay, this is 7 meter and this is 3 meter, let's say. Okay, and then let us suppose that we have chosen this corner as the origin. This is x-axis. Okay, this is y-axis and this is z-axis. Okay, now let us give names to all the vertices of this cuboid. Okay, so let me assign the names. Okay, let this be A, let this be B, C, D, E, F, G, and let this be H. Okay. If I now ask you what is the coordinate of A, it would be 0, 0, 0. The coordinates of origin, they are 0, 0, 0 because you need not move in any direction to get to any place from origin. Okay, so it would be 0, 0, 0. Now if I talk about coordinate of B, okay, from origin I need to walk only along x direction. I don't need to walk along y, I don't need to walk along z. So this would be 7 0 0. Okay, to go to C, I need to walk along x, I need to walk along y. So 7 4 0. To go to D, I don't need to walk along x, I will walk only along y. How much distance? 4. So 0 4 0. Let's notice one thing. You say that, sir, to go to D, I don't want to choose the direct path. I want to choose this path. I will go from A to B, B to C, and C to D. What is the problem in that? No problem. In going from A to B, you will move +7. Okay. Then this motion is along y-axis. We'll discuss that later. And this motion is along, again, parallel to x-axis, but in negative direction. So +7, -7. So x coordinate is again 0. So even if you choose to walk on a complex path, all right, what you will have to do, in some portions of your path, you may have to walk, in the positive direction of x, and in some other portion of that path, you may have to return back. So ultimately, you will get the same x coordinate as what you would have got with the simplest of paths. And therefore, in all parts of this question, or while writing coordinate of any point, I am choosing the simplest possible path, because why will I make my life complex by using complex paths? Okay, now regarding E, okay, to reach E, I don't have to walk along x, I only need to walk along y and then z. I need to walk 4 meters along y and 3 meters along z. Okay, so this is point E. What about H? To reach H, I don't have to walk along x, I don't have to walk along y, I only need to walk along z. So that would be 0, 0, 3. Okay, what about F? What about F? To reach F, along x, then y, then z. Okay, so 7, 4, 3. Okay, then to reach G, x and then z. So G is 7, 0, 3. So this is how we can write the coordinates. And if you really want to test yourself, let me give you 2 points. Okay, so this is your test. Midpoint of this face, okay, this is point x. Midpoint of the right wall, midpoint of the ceiling, write coordinates of these. So this is your test. Okay, you can write the coordinates of x and y in the comments. Okay, so this is how we mark points in the 3D space. All right guys, now what exactly is slope of a straight line? So guys, in xy plane, okay, let's say we draw a straight line somewhat like this. Okay, then this line, even if you choose to draw only this segment of the line, if you don't draw the remaining of the line, you can still imagine it to extend and cut the x-axis. Now whatever angle this line makes with the x-axis, tan of this angle is called the slope of the line. Okay, slope of line, and it is usually indicated by the symbol m. Okay, tan of this. Okay, getting it? So this is called the slope of the straight line. You should have some fair idea about this. Okay, now if we want to compare slope of two straight line, let's say even if I don't draw the coordinate system, this is one line and this is another line. This is line 1, this is line 2. Can you tell me which one of these has a higher slope? So you can imagine that if there would be an x-axis, they will cut x-axis and they will create angles, and they need not cut x-axis at the same point. Okay, they may cut at different points. So tan theta 2 will become the slope of second line, tan theta 1 will become the slope of first line. Because both the angles are acute, that means these angles will fall in the first quadrant when we try to mark them, and in first quadrant tan is positive, so both will have positive slope. All right, or you can remember it, anything which is inclined upwards, like if you are moving towards positive x direction and that leads to an increase in height, then that's called a positive slope. Okay, and this is a negative slope. Like if you are moving in the positive x direction and you are going downhill, then that is a negative slope. Okay, so both of these lines have a positive slope. The more the line is inclined upward, the more slope it has. Okay, so between these two, M2 will have a higher slope as compared to M1. Okay. So let me give you a question. Let me give you a quick question, students. Let's say this is x-axis. Let's say this is y-axis. Okay, and I draw 4 lines. One, I can draw anywhere. The location of the line doesn't matter. 2, okay, and 3, and let's say 4. Okay, so this is 1, this is 2, this is 3, and this is 4. Notice carefully. Okay, before I ask the real question, let me ask you some preliminary questions. Between these, among these 4 lines, how many lines have positive slope? How many lines have positive slope? Tell me, guys. Okay, so if you answered 1, you are wrong. If you answered 3, you are wrong. If you answered 2, you are correct. 2 of these lines have positive slope. And if I ask you how many of them have negative slope, then again, if 2 have positive, there are total 4. The remaining 2 has negative slope. The 2 positive slopes are 1 and 2. The 2 negative slopes are 3 and 4. Now, if I make a column match, okay, like I am writing 4 values of slope, you have to match them. So one place we have -2, -5, let's say +2 and +5. Okay, which matches with which? Okay, so this is what you have to do. Try to do it, everyone. Okay, so let's see. 1 and 2 have positive slope, 3 and 4 have negative. So these positive numbers, this is between 1 and 2. Between 1 and 2, which one do you think has higher slope? So this one is more steep as compared to this. Okay, if you have to climb your car on this one, you may still dare to do it. But if you have to climb your car on this one, you will probably never try to do that because it's highly steep. So 2 has more slope. 2 has higher slope. Okay, so L2 will go with +5 and therefore L1 will go with +2. Now between these two, they have negative. So more negative means more vertical. Okay. So 4 will go with -5 and this will go with this. So that's how we compare the slope of the straight lines. All right, students. Okay, so that's regarding that's the point in geometry that we need. Okay, now we are going to talk about determinants. Okay, now what are determinants? So determinants is a way to represent a data, but when you expand the determinant or when you try to find the value of it, you can get it. So there is a certain way. So determinant is like a table. Okay, so I'm making a 3 by 3 determinant. So this is called a 3 by 3 determinant. Why 3 by 3? It has 3 rows and 3 columns. These are called rows. So this is row 1, this is row 2, and this is row 3. These are called columns. So this is column 1, this is column 2, and this is column 3. So 3 by 3 determinant means that we have 3 rows and 3 columns. In a determinant, the number needs to be same. We can have 3 by 3 determinant. We cannot have a 3 by 2 determinant or a 2 by 3 determinant. Those things are called matrices. Again, you will study in detail in mathematics, but in determinants, the number needs to be same. Like it has to be a square thing. Okay. So we can have 4 by 4 determinants. We can have 2 by 2 determinants. A 1 by 1 determinant would be a simple number. Okay, one number, that is one element. So this 3 by 3 determinant contains 9 elements. We call these as 9 elements. They could be numbers, they could be formulas, they could be whatever. Okay, usually they are numbers. They are different numbers. So A is a number here, for example, A could be 2, B is a number here, it could be -4, something like this. Okay, so there is a certain way to expand this determinant. That is, once you put numbers here, it starts representing a value. I'll do this and probably that will explain you. Suppose I write 7, 2, 3, 1, 4, 8, 5, 6, 9. I've written random numbers. So this determinant represents a specific number. It represents a value. Now, what value does it represent? There are rules to that you have to follow. The rule is this. This represents. So in the first row, notice the first number, write it down. Okay. Then exclude this row, exclude this column, the number that you have written. All right, this number, whichever row it is part of, exclude that. Whichever column it is part of, exclude that. Once you do that, you will notice that you have now a 2 by 2 determinant. Okay, you will be left with 4 numbers. All right, now watch it. Product of this minus product of this. That means 7 will be multiplied by 4 into 9, product of these two, minus 8 and 6. Okay, once you are done, then you have to move to the next number. Now, let me erase this, let me erase this. So the job of 7 is done. The job of 7 is done. Now we will do the same thing with, the next number, which is 2. But when you move from, like, alternatively, we will keep on changing the sign. Now minus 2, like whatever number is present here, add a negative sign to it. Okay, then ignore this column, ignore this row. Okay, you can see 4 numbers. Again, this arrow minus this arrow. That means 1 into 9 minus 8 into 5. Okay. So the job of this is also done now. This is done, this is done. Okay. And now the last number. Okay, now again you will keep the sign same. Alright, so only the middle one changes the sign for a 3 by 3 determinant. So whatever sign is present, here 3 was written, that is plus 3. Okay, and again you ignore this row, you ignore this column, you have 4 numbers, this minus this. So 1 into 6 minus 4 into 5. And now evaluate. So this is 36 minus 48. So minus 12. 7 into minus 12 is minus 84. Okay, 9 into minus 40. 9 minus 40 is minus 31. Minus 31 into minus 2 is plus 62. Okay, then 6 minus 20 is minus 14. Minus 14 into 3 is minus 42. Okay, so the overall, I said that this determinant represents a number. That number is, this is 22. So minus 62. Yeah, minus 62 are we getting? $64, I think. Minus 64. Let me check it again. Yeah. Minus 64. So this determinant represented minus 64. So you have to learn this way of expanding the determination. Whatever I did here, okay, repeat that, view the video again and again. Or let me do another example with you guys. Let's try one more. Okay, let's take a bit of complex value this time, right? 3, 7, minus 4. I'm deliberately putting some negative numbers now. Okay, 5, minus 1, 3, minus 2, 8, 7. So let's find out the value of this determinant. Watch me. The first number, I will exclude this row, I will exclude this column. Then let me change the color of the pen. Then I will do this minus this. So it would be minus 7, the product of these two, minus 24. Okay, then I will get rid of, like, I'm done with this. Now the second number. Now the second number has to be written by a change of sign. So minus 7. It was plus 7, so I made it minus 7. Okay, then I will rule out this, I will rule out this, and now this minus this. So 35 minus 6. Please note this. This product is minus 6. So 35 minus 6. Okay, and now I'm done with this also. So I'll move my focus to the next and the last number, which is minus 4. Now notice that I'm writing a minus 4 here. but sir, you said that the third one has to be positive. Array, the third one doesn't have to be positive. The third one, the sign needs to remain same. Whatever sign this has, we'll bring that here. Whatever sign this has, we'll bring it here. For the middle one, we change the sign. Okay, so -4, and then this minus this, so 40 minus the product of these two is 2, and now you can calculate. So this will become 3 into -31. Okay, I'll do it in one step only. Three into -31 is -93. Then this one is 41. 41 into 7. 41 into 7. 287. -287. And here again negative value. This is 38. 38 into 4. 52. -152. So you can add these numbers, you will get the answer. Okay, how much will it become? This will become 532, I think. You can check this. Okay, so you focus on the process here. This is how we have to do the determinants. This is how we expand the determinants. All right, so guys, there are few points that you have to keep in mind. You need to practice this. Okay, usually students, when they learn the determinant for the first time, they commit errors. Okay, so this is a subject, or this is a topic which is prone to errors. So do not get frustrated if you are committing errors. Okay, once you practice enough, you will start getting it right. Okay, and if you don't revise this process, you will tend to forget it. Okay, so keep revising it. You will need it. Now, what are functions? Okay, so function word means, like, if I say y is a function of x, y is a function of x, then it means, okay, it means that y depends on x. It means that if you change the value of x, then you can expect y to change. Okay, it means y depends on x, and both of these things, they are mathematically, or rather symbolically, they are written. Mathematics, they are written y equal to fx. So writing y equal to fx means y is the function of x. Okay, I'll give you an example. Suppose I write y is equals to x square. Now you can notice that based on the value of x that you are choosing, y will change. Okay, for example, if you choose x as 0, y is 0. If you choose x as 1, y is 1. If you choose x as 2, y is 4. If you choose this as 3, this is 9. If you choose this as 3.5, then this is 12.25. Okay. So when you change x, y tends to change. So such a situation is called y is a function of x. Okay. Now suppose I write y is a function of x, and then I continue to write something like this: x square plus 2x plus 1. Okay, let's have written like this. Let's change it to 10. Okay. Then what does that mean? That y is a function of x, and that exact dependence, exact relation between y and x is this. Okay, now if I ask you to calculate f of 0, it means that in this expression you will replace x by 0. So it would be 0 square plus 2 into 0 plus 10. So it would be 10. Okay, if I ask you to calculate f of 1, okay, it would mean 1 square plus 2 into 1 plus 10. So that would be 1 plus 2, 3, 13. Getting it? If I ask you to calculate f of minus 1, okay, then it would mean minus 1 square plus 2 into minus 1. Basically here, wherever x is written, you will replace x by whatever is written here. Okay, so it will become 1 minus 2 plus 10. So that is 9. I hope this is clear to everyone. If this is clear, let me give you a question. Okay, let's say I have defined y as a function of x. All right, and let's say this is 3x plus 2. Okay, now calculate following. Okay, so first of all, let's say you want to calculate f of 0. Okay, then let's calculate f of 2. Okay, then let's calculate f of 5. Okay, then let's calculate f of minus 2. Now let's complicate things a bit. f of 2. Okay, getting it? All right, okay. F of 2 square, and g is f is square 2. Okay, so let me do this now. So we'll do it on the next slide. Okay, we'll keep on coming back. So a f of 0 is 3 into 0 plus 2, that's 2. Okay, then next one, f of 2. Okay, f of 2 is 3 into 2 plus 2, 8. Okay, I hope I remember the function correct. Yeah, f of 5. Okay, f of 5 is 3 into 5 plus 2, 17. Okay, next, f of minus 2. Okay, f of minus 2 is 3 into minus 2 plus 2. So minus 6 plus 2 is minus 4. There is one more thing, guys. It is not necessary to use f only. Whatever, like I could have used a g here or a h here, any small alphabet, but then we'll continue to use the same here. Okay. Now e was f of 2. So f of 2. Okay, this means f of, what was f of 2? This f of 2 was 8. So f of 2 means f of 8, which means 3 into 8 plus 2, which is 26. Okay, then next is f of 2 square. That's simple. F of 2 square is f of 4. So 3 into 4 plus 2. So this is 14. Okay, g was f is square 2. F is square 2. F is square 2 means f of 2 into f of 2. F of 2 we calculated to be 8. So this is 8 into 8. This is 64. All right. So are we done? Yeah. So all the values we have found out. Okay. And we may work with two functions also. For example, there could be questions like this also. Like I said, f of x is x plus 1. And then I said, okay, g of x is, or we can use another symbol also. Like it's not necessary to keep on using x. It can use, like, I erased it. Okay. Yeah, okay. I can say g of t is, let's say, t square. It basically means that whatever you have written here, the same number should appear here. So the symbols can change. Okay, now let's say find f of g1. Okay, or g of f1. Getting it? Let's see what this means. G1 is how much? It's 1 square, that is 1. So f of g1 would mean f of 1, because g1 is 1, and f of 1 is 1 plus 1, that is 2. Okay, so that was first part. Second part, first let's calculate f of 1. F of 1 would be 1 plus 1, that is 2. Now g of f1 would mean g of 2, which would mean 2 square, so this is 4. So I hope you get it, that what does these functions mean. Okay, we'll be requiring them, so you need to understand what is going on here. All right. So that's it for today, guys. You will find some assignments in the description of this session. Please attempt those assignments before the next session. I'll see you in the next session, guys, where we begin the calculus part. Take care, everyone. Bye bye.